So the beauty of using transformations to graph is you can use them on any function. And that's what we're going to exploit in this video is we're going to start with generic parent function and apply transformations to it. We don't have to know a formula for the function or anything, but transformations still work. So let's start by recalling a little bit about our transformations. Make sure we're all on the same page here. So first thing, X transformations. X transformations reverse the arithmetic inside the parent operation. Remember, they happen in reverse. Y transformations. Y transformations are the arithmetic outside the parent operation. So they don't reverse the arithmetic, they follow it. Let's see, addition and subtraction. Those give us shifts. Multiplication, division by -1 specifically give us reflections. And multiplication, division by a positive number give us stretches or shrinks, compressions. Okay, so that's the foundation we're going to be working on. Let's do an example. So let's say given the parent function f below, so I'll give you a parent function shortly. Given the parent function f below, use transformations to graph. Let's just look at y equals 2 times f of x minus 1. Okay. All right, let's see how this works out. So first things first, I'll walk you through how to draw the parent function in case you're taking notes. So we need to graph the function f. Let's set up a grid. And we'll go by ones on each axis. So let's plot a point at -6, -2. So -1, 2, 3, 4, 5, 6. -2 is right here. Okay. Then let's plot a point at -4, +4. So left 4 and up 4. Let's plot a point at 0, -4. And let's plot a point at, how about 4, 6? So 1, 2, 3, 4, 5, 6. And we're just going to connect these points sequentially with straight lines. So it's this piecewise looking function. So this is the f function. I'll color code it in black. So this is the f function. And what we want to do now is graph this transformed version. So this is, if you want, actually let's do this. It is the f function, but it can also be written as y equals f of x. Okay? And we're trying to graph this transformed function. So first thing I want to do is I want to represent my parent with an xy table. My parent is y equals f of x. And when I'm building my xy table now, I don't have a formula to calculate my y values, but I have a graph. So what I'm going to do is pick as many points as you want. But I'm going to pick the 4 corners, the 4 vertices of this function. So the first one we graphed was the point, let's see, 1, 2, 3, 4, 5, 6. So -6, -2. Then we got -4, +4. Then we got 0, -4. Then we've got 4, 6. So I'm going to track those 4 vertices through the transformations. Now, what are the transformations? Well, inside the parent operation. Well, inside the parent operation is inside the f function. And we can see that we're subtracting 1 from x. So our x transformation is going to be to add 1. So I'm going to go to my x column and I'm going to add 1. Remember, the x transformations reverse your operation. The y transformation is what happens outside of the parent operation, the f operation. So that's times 2. So y is times 2. So now I can generate my xy table for my transformed function because I've got all my transformations. Let's add 1 to all the x's, -5, -3, 1, and 5. Let's multiply our y values by 2, so -4, 8, -8, 12. And all we have to do is plot these points to see what our graph looks like. Now, before we do that, understand what these transformations do. Adding 1 to x is going to move the graph to the right one. Multiplying y by 2 is going to stretch it vertically. So we should imagine this shape moved to the right one and stretched out taller. That's what it should look like. So -5, -4 is right here. -3, 8 is up here. 1, -8 is down here. And 5, 12, so 5 would be 1 over, and then 12 would be twice as high. 6, 7, 8, 9, 10, 11, 12. And now I'll just connect those points with straight lines because I know the graph is made up of straight lines. Transformations won't ever cause a graph to curve if it didn't curve before. It just stretches it, shifts it, reflects it. And so what we've done is we've taken the original parent graph in black, shifted it right one, and stretched it vertically away from the x-axis. So this red graph is our transformed function, y equals 2 times f of x minus 1. And that's our final graph. So transformations work on any parent function. Let's do one more example just to make sure we've got this down. Okay. Given the parent function, I'll even say it as y equals f of x. Below, use transformations to graph y equals, how about -f of 3x. And actually, I'm going to use the same, let's make a different parent function real quick. That's no problem. Let me put a grid on here. Now that we know what we're going to do, let's go ahead. Well, let's plot the points. So let's have our first point at -9, 3, 4, 5, 6, 7, 8, 9, -9, 5, 1, 2, 3, 4, 5. Then let's have another point at -4. Let's do -4, 1. And let's just do one more point at 6. How about 6, 7? So 1, 2, 3, 4, 5, 6 to the right. 1, 2, 3, 4, 5, 6, 7 above. And for simplicity, we'll connect those with straight lines, so we don't have to worry about trying to match a curved shape. And this will be the graph of our parent function, y equals f of x. So again, the parent, y equals f of x, has an xy table. This time I'm just going to plot the 3 vertices. So what was this first one? -9, 5. The next one was -4, 1. And last we had 1, 2, 3, 4, 5, 6, 7. Okay, so now we just need our transformations. The x transformation we can see here inside the parent operation, we're multiplying by 3. So that means we'll go to our x column and reverse that and divide by 3. And in the y column, we're multiplying by -1 outside of the f function. So we'll multiply the y values by -1. Now what's this going to do? Dividing x by 3 is going to squeeze our graph towards the y-axis. It's going to shrink it horizontally by a third. And multiplying the y values by -1 is going to flip it over the x-axis. So let's see what we get. Dividing the x values by 3, we get -3, -4 thirds as a fraction. That's -1 and a third. And 6 divided by 3 is 2. Then we just change the signs of all of our y's, -5, -1, -7. And let's plot those points. We'll do that in red. So -3, -5, 1, 2, 3, 4, 5. That's where this point used to be. So this point has been compressed towards the x-axis by a third. It was 9 units left. Now it's only 3 units left. And it was 5 units up, but now it's multiplied by -1 and it's 5 units down. So it's compressed towards the y-axis and flipped over the x-axis. -1 and a third, -1, so -1 is here, -1 and a third is right here. -1, that's down here. That's this point, compressed towards the x-axis and flipped over the x-axis. Sorry, compressed towards the y-axis and flipped over the x-axis. Our last point is 2, -7. So that's this point compressed towards the y-axis and then flipped over the x-axis. And now we can just connect our vertices with straight lines. And this graph is the graph of y equals -f of 3x. So compressed towards the y-axis and then flipped over the x-axis. That's all there is to it, the power of transformations.